In this video, we will prove that medians of similar triangles are also similar. So here we have our givens and proof, also down here, and we'll do the proof here and put it on the diagram over here. So first thing, triangle ADC is similar to triangle EGH. One thing to note about similar triangles, they are named so that corresponding vertices are named in order. So vertex A corresponds to E, D to H, and C to G. So then angle A is congruent to angle E there. Then angle ADC is congruent to angle EHG. And then angle C is congruent to angle G over there. And then side AD is similar or proportional to side EH. Notice that we're doing this with squiggly lines rather than straight marks, meaning similar rather than congruent. Then DC is similar to HG. And then AC is similar to EG. From there, we have DB and HF are medians given. So DB and HF are medians. That means that AB is congruent to BC, and then EF is congruent to FG. Again, note the red straight tick marks mean congruent, and the squiggly green marks mean similar or proportional. Next, we will get to the algebra portion of our proof. AD over EH equals AC over EG. Corresponding sides of similar triangles are proportional. And we'll do this in orange just to set it off. So we have AD over EH equals AC over EG. Then we will multiply the top and the bottom by 1/2 over 1/2, giving us AC over 2 over EG over 2. And that brings us to this line, AD over EH equals AC over 2 over EG over 2, because 1/2 over 1/2 equals 1. We simply divided the top and the bottom by 2 to get to here. So next, AB equals AC over 2 and EF equals EG over 2. Definition of median. Coming up to the diagram, we can see that AB is half of AC because AB and BC are congruent. And by the same argument, EF is half of EG. So then AB equals AC over 2 and EF equals EG also over 2. And then substituting in AB for AC over 2 and EF for EG over 2, we have AD over EH equals AB over EF. And now we have this line in our proof, AD over EH equals AB over EF, substitution. Now, these 4 lines of the proof are the crux of the proof. You're probably going to have to go through this 2 to 3, maybe 4 times before it really makes sense. Just make sure you take the time to go through it. So now that we have our substitution, we can see that AD over EH equals AB over EF. So we can say that AB is proportional to EF. So we'll mark that on the diagram. So we'll do a circle and a squiggly mark and a circle and a squiggly mark there. AB is similar to EF. From there, we have triangle ADB is similar to triangle EHF because of SAS similarity. We have a side, an angle, and a side here. We have a side, an angle, and a side here. Therefore, DB and HF are proportional because corresponding sides of similar triangles are proportional. And since we have SAS proportionality between triangle ADB and triangle EHF, and we already have these 2 sides here and here, this is the third side. So then DB is proportional to HF. The reason this proof is much more difficult is because of this right here. We're doing algebra inside of a proof, which most people are not used to. And it's a fairly intricate thought process. And this may take you 3 or 4 times running through it before you get it, but definitely do the work. You will find in academics, the main difference between the people who kind of get it and the people who really get it is simply that extra 2 times running through it. So as we like to say here, do the work, conquer it, and then you can move on.